Concept and a principle of prestressing in prestressed concrete. So, what is a prestressed concrete? It is a form where the concrete was given initial compression before applying the external load, so that stress from the external load are countered in the desired way during the service period. There are three types of the prestressed concrete. There are pre-tension, bonded, and unbonded post-tension concrete. Concept of prestressing in prestressed concrete are taken from the wooden barrel concept, where the first metal are being wound around the barrel. This will create a tensile prestress, causing the wooden to receive a compressive prestress from the metal wound. This will enable the barrel to resist tension produced by the liquid in the barrel. The concept be taken to the principle of the prestressed concrete, where, as you can see here, this is an unstressed beam where when it given a load, it will deflect. So we use tendon at the first to stress the tendon concrete. Then after the concrete will adjust to the bar, and when it release, it will transfer the concrete as a compression by static friction. This will causes the concrete to bend, as you can see here. And then when the load are being applied to the concrete will have the counter ability of the load. So this is the principle of the prestressed concrete.
Our daily life, we see the many things to happen. Sometimes we ignore them, but sometimes it clicks our mind that how it is working. What is the principle behind that? If you are one of them, then don't worry, because you are on Civil Beats. Here you will get detailed description about the principle working behind them. So without wasting much more time, let's begin the today's topic, which is known as prestressed concrete. Firstly, let's understand the concept behind the name of prestressed concrete. As the meaning of prestress is that it is already in stress. When any type of load is applied on any material, then different types of stresses are produced depending upon the nature of the load. Produced stress may be tensile stress, compressive stress, shear stress, bearing stress. Suppose if we are applying a load on any structure which will produce a stress in that material, what if an opposite stress is already present, which will counteract the stress produced by the load? Due to this already present stress, structure will work very effectively, and can bear the extra load, compared to the simple reinforced concrete. If we talk about the simple reinforced beam, if load is applied on that beam, if it is simply supported beam, then compressive stress is generated at the top of beam, and tensile stress is generated at the bottom of that beam. As we already know that concrete is much better in compression than tension. For design purposes, we neglect the tensile strength of the concrete, because it is very low. That's why, to make beam sustainable in the tensile stress also, we provide the steel bars in tension zone. Prestress is also the same, but the only difference is that we provide compressive stress in the bottom of beam before application of load, by pulling of steel wires. We take an example of a rubber band. If we stretch it and hold by an apple, then it tries to compress that apple. Same thing is used during making a prestressed concrete. Prestressed concrete is prepared by the two methods. First one is pre-tensioned concrete, and second one is post-tensioning concrete. Never be confused between the prestressed concrete and pre-tensioning concrete, because pre-tensioned is the method to prepare prestressed concrete. In pre-tensioned concrete, firstly steel wires are pulled, which will further act to produce compressive stress. After stretching of the steel wires, concreting is done. When concrete achieves its characteristic strength, then the grip of steel wires are removed. As we remove the wire grip, it tries to compress the concrete, which produce compressive stress in the bottom of beam. In post-tensioning concrete, a beam is casted firstly. During the casting, pipes are provided at the tension zone of the beam, which is at bottom for a simply supported beam. When concrete achieves its characteristic strength, then steel wires are inserted in these holes. Then these wires are stretched using hydraulic machines. After stretching, these wires are hauled up at the end and filled with the concrete. The principle of post-tensioning beam is same as the pre-tensioned beam. If you like this video, then you can show your support by like and share this video. For more new technologies videos, you can subscribe our channel.
Okay, procedure for pre-tension prestressed concrete. The first one, the tendon and the reinforcements are positioned in the beam mold. The tendon are stressed to about 70% of their ultimate strength. Then the third one is concrete is cast into the beam mold and allowed to cure to the required initial strength. And the fourth one, when the concrete has cured, the stressing force is released and the tendon anchor themselves in the concrete. For post-tension procedure for post-tension prestressed concrete, first one, cable duct and reinforcement are positioned in the beam mold. The duct are usually raised toward the natural axis at the end to reduce the eccentricity of the stressing force. So the second one is concrete is cast into the beam mold and allowed to cure to the required initial strength. The third one, the tendon are threaded to the cable duct and tension to about 70% of their ultimate strength. And lastly, wedges are inserted to the end of the anchor and the tensioning force on the tendon is released. The grout is then pumped into the trough to protect the tendon.
Third question is discussed with fact why precast concrete is preferred compared to conventional in situ construction method. The first reason is the quality control. Because precast concrete is mixed, poured, and cured in a factory, ideal condition and exacting measurements can be maintained throughout the process. Unfortunately, the logistics of site casting make this far more challenging. You are subject to the humidity and temperature of the day you are doing the casting. You must do the work using far less precise tools. The result is an inferior quality product even under the most ideal condition. The second reason is labor efficiency. Precast is much more labor efficient. Because work is done in a factory, the effort is maximized using tools and machinery that simply is not available on the job site. Therefore, with site casting work that might be done with machines has to be instead performed by hand. This is much more labor intensive, thus increasing labor costs and making the process more costly. The third reason is the curing conditions. Because curing conditions can be controlled in a factory, they can be accelerated without sacrificing strength or quality. That simply is not the case on site. While you can do certain things to accelerate curing on site, they are difficult and generally not worth the logistic hassles and costs. Furthermore, they run the risk of lower quality concrete, as delicate variables are hard to account for. If you need accelerated curing, precast is the only way to move forward confidently. The next reason is weather. An unexpected rainstorm can bring construction work to a halt if it occurs when you are doing site casting. Thankfully, this is not a problem when it comes to precast solutions. If it is raining when you are casting slabs that arrive on your site, you can lift them into place just as you would do during the sunny day. Last but not least, finally, specialized reinforcement. Just as specialized insulation can be added to precast concrete, specialized structural reinforcement can also be added as well. For certain projects, this is crucial as it allows the panel to bear loads at a thickness that simply is not possible with traditional poured concrete. By decreasing the amount of material needed to make a building structurally sound, you are saving money while being less taxing on the resources available.
Why precast concrete is a green concrete and a sustainable construction method? Because the precast concrete is being made in a controlled condition, making the amount of energy being used is less inefficient due to mass production. Other than that, precast concrete is also recyclable, where unused concrete blocks can be crushed into small aggregates and used back in making new concrete structures or as aesthetics decoration in parks, thus reducing amount of carbon dioxide being released due to disposing construction material. Indoor air quality is improved as the precast concrete material is composed of natural occurring elements, making it have no volatile organic compound that off-gas toxic chemicals. Concrete finishes inside the buildings have an attractive aesthetic appearance and reduce costs by eliminating other type of finishes.